Hello, welcome to class number 7 of Engineering Economics. This class is gonna cover sections 4.1 and 4.2. The author titles this chapter Present Worth Analysis. We already know how to find the present worth of different kinds of cash flows, but this is going to apply that knowledge to certain kinds of situations and different kinds of ways to form project alternatives from projects that have different kinds of dependencies or are independent of one another. So that's what we're going to do. By the way, I've revised the schedule, so as I always say, go to the start page and look at your schedule of assignments. I put in the week that was kind of lost due to Hurricane Laura, and so we're pushing the schedule back a little bit, but it's not something that's going to affect the total amount that we'll cover. We'll still cover the entire course. The second thing I want to mention is that what we're covering in this lecture is pages 108 through 114 in the ebook or smart book, whichever you prefer to use, and we're talking about forming investment opportunities from one or more projects, and this instructor video will be posted online in Module 4, which goes with this Chapter 4, and these lecture notes also, which I will write on and then scan, and they will be posted also in Module 4 on Blackboard. I want to emphasize, I think I've said this before, but just to be sure, I want to emphasize that if you wish to make a good grade and really learn this material, there's no substitute for working lots of problems. And so the homework problems that are actually part of your grade, a major part of your grade, are considered just a minimum. I suggest you go to the back of the chapter and you work several problems before you even try to do the homework problems. So the more problems you work, the more accustomed you get to understanding the way the author is wording problems, because the hardest part of the course is understanding what the problem is. It's not the solution to the problem. So the only way you gain experience with that is by working problems. So we're going to start now in section 4.1, which discusses formulating alternatives. So when you have more than one project under consideration, sometimes those projects are dependent on one another in certain ways, and in other cases they may be independent. When they're independent, there's a lot of projects. We generally call that a capital budgeting decision, and those kinds of decisions are made at the very high levels of a corporation. A practicing engineer, certainly not a young engineer, is probably not going to be in on those kind of decisions, but you may be doing the engineering economic analysis that leads to those decisions. So you need to know what's behind those kinds of things. So the author discusses what he calls mutually exclusive alternatives. So suppose you have 3 projects, A, B, and C. If those projects are mutually exclusive, that means you can do at most one of them. It makes no sense to do all 3 of them, or even 2 of them, because they do the same thing. So you're going to do either project A, or you do project B, or you do project C, or you do none of them. That's a possibility in some cases, in most cases, in fact. The only case where you wouldn't consider the do nothing alternative is where either there's no revenue or the only revenue is a salvage value. So if there's no revenue given, obviously the present worth would be negative, and you wouldn't look kindly on that kind of a project. However, in some cases, you're just trying to minimize costs. There is revenue, but you don't estimate it. So we're going to look at the case where we have mutually exclusive projects first. And in that case, say there are M mutually exclusive projects, there are going to be M plus 1 mutually exclusive alternatives. One alternative for each project, and then finally the do nothing alternative. So for example, when we had projects A, B, and C, we had 3 projects. We're going to have 4, M is 3, we're going to have 4 alternatives. Do nothing, do A only, do B only, do C only. Okay, that's if they're mutually exclusive. The next case I'm going to discuss is where the projects are independent of one another. Now, this means that your decision about one of the projects has no effect, no bearing on your decision about the other projects. So these are 3 totally different projects. They could be in different areas of your company, and if one of them is good and another one is good, you could do both of them. Or you could do all 3 of them, or you could do, if there were M of them, you could do all M of them. So in that case, if they're independent, and there are M of them, there are 2 to the M mutually exclusive alternatives. That's a lot, okay? Because for every project, you can either do it or not do it, so you have 2 choices, and then there are M projects, so that's 2 to the M power alternatives that you could form. So obviously, if M gets big, there's a lot of them, okay? I only give an example where there are only 3 projects that are independent, okay? Okay, there are M independent projects, then there are 2 to the M mutually exclusive alternatives. So these alternatives that you form from the projects, you'd only do one of them, but one of them may contain many projects. So I give the example, suppose that you had 3 independent projects, D, E, and F, and now you're going to form alternatives. Well, since there are 3, there would be 2 to the 3rd power, or 8 alternatives that you can create from these 3 projects. And we'll start with the first alternative is to do nothing. Okay, that alternative has none of those 3 projects in it. Then you would have 3 alternatives that only have one of the projects. So do D only, do E only, do F only. Or you could do 2 of the projects, D and E, D and F, E and F. Or you could do all 3 of them, and when you run all the possibilities, you end up with 8 mutually exclusive alternatives. So I say the do nothing alternative is only considered if the projects have revenues. If there are no revenues, or if the revenue is only a salvage value, for all practical purposes there's no revenue, then the do nothing alternative is not considered, because you wouldn't even be looking at these projects if you didn't have to do one of them. So the do nothing, if there are no revenues, then you just take away the do nothing alternative, which would reduce the number of alternatives that you can form in either case, whether they're mutually exclusive or whether they're independent. It would reduce the number of alternatives by 1. So in this case, for example, where you had 8 alternatives, it would be 7. You wouldn't consider that do-nothing alternative. And when they were mutually exclusive projects, you could only form 3 mutually exclusive alternatives from that. So the next section, we're going to look at mutually exclusive alternatives. And the author gives an example. He presents a table on page 112, and in that table, each row represents an alternative. And he deals with selecting which alternative of the 2. Okay, so row 1, you can either do a project 1 or a project 2. Project 1 has a present worth of minus 1,500, and project 2 has a present worth of minus 500. Now, we're going to assume that the do-nothing alternative is not allowed, because if it was, you'd certainly select it. It has the highest present worth of 0. But we're assuming that the do-nothing alternative in row 1 is not feasible, so we would select alternative 2 because it has the higher present worth, less negative. Similarly, row 2, you have 2 alternatives. One has a present worth of minus 500, the other plus 1,000. Certainly 1,000 is better than minus 500, so you'd select that one. Alternative, or row 3, you're presented with 2 projects, 1 and 2. Project 1 has a plus 2,500 present value when calculated at the MAR. Project 2 has minus 500. So project 2 certainly wouldn't be considered. You'd select 1. And finally, row 4, you're looking at 2 alternatives, 1 and 2. The 1 has a higher present worth, so it's selected. Both of them have positive present worths. Now, if these were independent, you'd select both of those, but they are mutually exclusive, so you have to select one or the other, or none. Okay. And in row 1, I've assumed that the do-nothing alternative is not feasible. That's not real clear in the textbook, but that's the only way you can do that and get alternative 2, because he's not looking at the do-nothing. He doesn't list the do-nothing alternative here. So we only have the choice of this or this. The next example that I'm going to present is example 4.1, which is also listed on page 112 of your ebook, your smart book. There are 3 mutually exclusive alternative ways to supply power. Now, basically, supplying power does some good, and we're not sure what the revenue is, so the only things that are listed are cost. So we're in a cost minimization, and the do-nothing alternative is not being considered. So the only revenue given is the salvage value. So that's the only positive cash flow here. So for all practical purposes, no revenue problem, and so we're trying to decide, should we provide electric power, should we provide gas power, or solar, which is the least expensive, okay? And the author gives a MAR of 10%. So let's look at the present worth of the electric power alternative. So I'm going to write an equation, present worth sub E at 10% equals, well, we have a first cost of minus $2,500, so I'll just put that here, minus $2,500. Then we have an annual operating cost. That's what AOC always means, and that's dollars per year. So that's a uniform series. That's an A series, and that's for 5 years. Each of these projects are 5 years. So this is going to be minus $900 a year. And if I want the present worth, I'm going to get P given A 10% for 5 years. So I've counted for that. I've accounted for that. The only other thing is that there's a salvage value of $200. And so we'll put the 200 out here. And that is a single payment, okay, at time 5. So that's going to be P given F at 10% for 5 years. And we would get some number. We're going to do the same thing for gas, same thing for solar. Present worth of the gas at 10%, that's DeMar, equals, and this one, it costs more to install, minus $3,500, but your operating cost is a little bit less, $700 per year. P given A, 10% for 5 years, and then you have a little more salvage value, $350. P given F, 10% for 5 years. And then finally, the author gives you the option of solar power. Present worth of solar at 10% is equal to, and it's minus $6,000 now at time 0. But then your operating cost for solar is only $50 a year, so it's P given A, 10 and 5. And then your salvage value is $100. P given F, 10 and 5. And the author works this out for you, and his result is presented in the text, and it shows, for example, when you work the numbers, you get minus 788 for the electrical, for the present worth. I'm sorry, minus 5,788. For the gas, it's minus 5,936. And for solar, it's minus 6,127. So obviously the least negative or the most positive or the highest number there is this one. So you would use the electric in this particular example. Now, the next section deals with bonds, and bonds are a very unique kind of investment. There, I have also already mentioned that two things that are called securities, there's many other maybe, but the most common two are stocks and bonds. And so bonds are a form of an investment. And the author gives equation 4.3 that represents the dividends or the interest payment, and that's a capital I equal VB divided by C. V is the face value of the bond. B is the bond dividend rate per year, so it's an interest rate like, and C is the number of times the dividends are paid per year. Now, most corporate bonds have a face value of $1,000. Most corporate bonds pay dividends quarterly, so C would be 4, and then they pay different rates depending on the going rate in the market, and also depending on how stable this company is as an investment. So if the company is not financially stable, then they would have to pay a higher dividend rate to get you to buy their bonds. Now, every bond has a cash flow that has a certain form, and I'm going to draw that form up here. Every bond that pays a dividend on a regular basis. Now, most corporate bonds do this. Like I said, almost all corporate bonds pay dividends on a regular basis, which forms an A series. So if I look at this, your dividends start the first period after you buy the bond. Usually that's 1 quarter. And then so you have a dividend here, I, and another one here, I, and another one here, I, and that goes on until some point in time when the bond matures, if you buy this bond and hold it till its maturity date. Now, when the bond matures, this is called a maturity date. When the bond matures, you also get the face value back. Now, we're going to use this to do a specific bond. This particular bond that we're going to look at has a face value of $1,000. And in the next example, it will have well, I'll wait and go to that example. First of all, there's one other element of this cash flow that I've left out, and that's how much you pay for the bond, which is the price. I used a little p to represent that, but that's my choice. But basically, what you're going to do is you're going to pay something now, and what you're going to receive is a uniform series and a future value. This future value is known if you hold the bond to maturity. If you don't, if you get along here at some point in time and this bond has not matured yet, but you want to sell it, you can sell it on the open market. You just have to call your brokerage term and tell them you want to sell it, and they'll find you a buyer. And when you agree on a price, you sell it for a different price than what you bought it for, most likely. But it's not known what it will be because it depends on the interest rates. Generally speaking, bond prices go up when interest rates go down, and vice versa. So they go in the opposite direction of interest rates, the bond prices. So the next thing we're going to do is work an example. This example is ABC Corporation issued. So they already issued these bonds on this day 10 years ago. So these bonds that I'm looking at now by ABC Corporation, perhaps I called my broker, my financial advisor, and I said, I want to buy some ABC bonds. And he said, I have some for sale. One of our customers wants to sell them. That customer bought the bonds when they were issued 10 years ago. They don't want to wait because these are 30-year bonds. By the way, most corporate bonds are issued at the issue date. They mature 30 years from now. So this bond had a maturity date of 30 years from the date of issue. Okay, so it's 10 years old now. So what's its maturity date from now? 20 years, right? Okay, so it's if I buy this bond, I've got 20 more years left if, in fact, I choose to keep it until it matures. Okay, the face value of the bond is 12%. So face value of the bond is $1,000. V is equal to 1,000. And the dividend rate is 8% payable quarterly. Well, that's 8% per year, okay? Per year. I said the annual dividend rate, okay? So B is equal to 8%, or as a decimal, 0.08. And I am the investor, but I want to make 12% per year. So my MAR is 12% per year, and I'm going to say compounded quarterly. And I said that because these bonds are paying quarterly dividends. It says this 8% payable quarterly. That doesn't mean you're going to get 8% per quarter. It means that C is 4. So your dividend I from equation 4.1 is VB divided by C, which is 1,000 times 0.08, that's the annual dividend rate, divided by 4, because it's going to pay 4 dividends a year, 1 each quarter. And that's going to come out to be $20. It's going to pay 2% per quarter, okay? So if I buy this bond, I'm going to pay a certain price for it now. The question is, how much should I pay if I want to earn 12% per year compounded quarterly? Wow, okay, that's a high rate, okay? So this bond is going to pay me $20 every quarter. So this is 20. And it's going to keep doing that, by the way, until 20 years from now, which is 80 quarters. So I'm going to have a uniform series of $20. Then at the 80th quarter, which is 30 years from when it was issued, 20 years from now, I get the face value, V. V is equal to $1,000. So that's my cash flow if I buy the bond. Question is, what should I pay for it if I want to earn 12% per year compounded quarterly? So I have to find the present value of that cash flow at that interest rate. Well, 12% compounded quarterly turns out to give you your nominal quarterly rate, R quarterly, is 3%, right? And then, but I quarterly is also going to be 3% because it's compounded quarterly, so M would be 1 in your effective interest rate equation, where you're looking for I quarterly. Why do I want I quarterly? Because I have quarterly cash flows. So the solution is, you're given all this stuff. The present worth of that cash flow is $20 times P given A, 3%. This is $20 per quarter, 3% per quarter for 80 quarters. And then you have $1,000 out here. P given F, 3% per quarter for 80 quarters. You work through that and you get $698. That's all I should pay for this $1,000 bond because I want to earn such a high interest rate. Well, in real life, I say at the end of the example, in real life, you're not going to be able to buy this bond for $698. In fact, if you could, I'd be questioning how financially stable this company is if you could buy it for that price. Because normally, over the last 10 years, bond prices have been going up, not down, okay? And the reason is because interest rates have been coming down over the last 10 years, and therefore bond prices have been going up. So it's really unrealistic. You'd probably, to buy this bond that has this dividend stream and that future value, you probably have to pay more than $1,000 for it now. And you certainly would not earn 3% per quarter if you did. And so that concludes this lecture. And in the next lecture, we'll complete this chapter, and I'll work some problems as well. Thank you.